In this video, we are going to derive the derivative of the arcsecant of x. So pretty much what that means is we're going to derive the pretty much the derivative of the arcsecant of x. Now, we may not know what the derivative of the arcsecant of x is, but we do know the derivative of the secant of x. So what we're going to do is we're going to say that, y is equal to the arcsecant of x. If this is true, then that means that x is equal to the secant of y. So pretty much all we have to do is take the derivative of both sides with respect to x and then solve for dy over dx. And that will give us the derivative of the arcsecant of x. So pretty much we just got to do that, right? We'll take the derivative of both sides with respect to x. Okay, so now that we've done that, we pretty much are doing this, right? So pretty much we're going to evaluate each of these. So the derivative of x, we know, is just going to be 1, right? As for this, we know that the derivative of the secant of y is just going to be the secant of y times the tangent of y. Except that's not all. Because this, we have to take the derivative of this with respect to x. So that means we have to multiply by the derivative of y with respect to x, right? And so this is just the idea of using the chain rule. So we multiply by dy over dx. And so now that we have that, we actually have the ability to solve for dy over dx now. So I'm going to move over here now. And so solving for dy over dx, sorry, I'm going to do it up here. Dy over dx will just equal 1 over the secant of y, right, secant of y times the tangent of y. So this is what we get for dy over dx. So it's pretty much 1 over the secant of y times the tangent of y. So now that we have this, how do we pretty much go further with this? Well, this is given in terms of y. All we have to do is rewrite what y is in terms of x. Now, we could substitute what we had here into both of these y's, but that's going to make things a little complicated, like secant to the secant of secant negative 1, tangent of secant negative 1. It's just going to make things complicated. So what we could do is we could treat y as an angle, because if we take the secant of something, it's usually the secant of an angle, right? And tangent of an angle. And so we're going to treat y as the angle of a right triangle, right? So I'm going to draw a triangle, and pretty much I'm going to draw the triangle right here. Right, this is our right triangle. And so the whole idea is we're going to say that the angle y is right here, right? So this is angle y. Now, pretty much in order to find the secant of the y and the tangent of y, we have to know what these side lengths are. So how do we do that? How do we figure out these side lengths? Well, we're already given the ability to find those side lengths because we know right here, okay? We know that the secant of y is equal to x over 1. That's all we need to find the side lengths, right? Because the secant of y is just hypotenuse over adjacent, so secant of y is x over 1. So now that we know these side lengths, we pretty much just need to find this side length, which we can just do that using the Pythagorean theorem. So it's just going to be the square root of x squared minus 1, right? And so now that we know these side lengths, we're able to figure out the derivative of y with respect to x. All right? And so we're going to do that. All right, so continuing to simplify this, we get dy over dx is equal to, pretty much what we have here is 1 over, right, the secant of y. Now the secant of y is just hypotenuse over adjacent, so it's just going to be x times 1. So we have x. All right, and the tangent of y is just opposite over adjacent, which is just the square root of x squared minus 1. Okay, but is this correct? What about this length x right here? What if x is negative? x has the ability to be negative, doesn't it? But what if x is negative? Is that even allowed? If x is negative, can the length of this hypotenuse really be negative? No, the length of the hypotenuse cannot be negative, right? Because the way you find the length of hypotenuse is it's pretty much this, like the length of a hypotenuse can't be negative, right? And so the idea is that we have to put the absolute value there because the hypotenuse, it can't have a negative length. And so this is really what the derivative of the arc secant would be. So that's pretty much it, right? The derivative of the arc secant of x is equal to 1 over the absolute value of x times the square root of x squared minus 1. And so this, right, this right here, this is it.